Well, maybe some of you were probably hoping that I have just disappeared for the semester. No, I am back with another friendly installment of awesome statistics for you guys. Let me just talk briefly to you about how the rest of the semester is going to play out. Uh, Technically speaking, in terms of material, I'm getting ready to finish up week 8, which is introducing hypothesis testing to you guys. The next installment will be a little bit about hypothesis testing. So in what will be week 9, I will go through hypothesis testing, how to do it, as well as I'll be introducing something called a correlation coefficient with you so that we can finally get to regression, which is my favorite chapter in all of stats, and we'll pick that up after Thanksgiving. So the rest of the semester is going to go extremely fast. So fasten your seatbelt and let's talk a little bit about hypothesis testing. All right, so in this chapter, what are we going to do? And many of you have already kind of looked at the homework, and the feedback you're giving me is it's very common sense. This stuff you kind of get. It is common sense. And so what we're going to do here is figure out what is a null hypothesis, what is an alternative hypothesis, and learning how to state those, going through type 1 errors and type 2 errors. Now, folks, I will tell you, I will test you on type 1 and type 2 errors in terms of examples like I did in the lecture quiz. All right, so make sure on your note card you're going to want what is a type 1 and what is a type 2 error defined for you. Okay, we'll talk about this thing called a level of significance. This is something you've already seen before. You've heard me refer to alpha. You'll figure out in this hypothesis test whether or not it's one-tailed or two-tailed and how to find this quote-unquote p-value, okay? And then from this, we'll make and interpret a decision and write a claim for the hypothesis test. Okay, so what the heck is a hypothesis test? A process that uses sample statistics, okay, so we're going to use sample statistics to test a claim about the value of a population parameter. Okay, so in other words, we're going to use X bar to test a claim about mu. Okay, for example, an automobile manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. To test this claim, a sample would be taken. If the sample mean differs enough from the advertised mean, you can decide the advertisement is wrong. Okay, so what's a statistical hypothesis? This is going to be a statement or claim about a population parameter. Right? We need a pair of hypotheses, one that represents the claim and the other its complement, or you can think of it as an opposite. Okay, so again, we're going to have some statement or claim. All right, this is going to be about mu, our population. This could be our population mean. It could be about sigma, our population standard deviation. It could be about script p, our population proportion. All right, and so regardless of what we're going to have a statement or claim about, we're going to need two hypotheses. With one of these hypotheses, when one is false, the other one must be true. All right, well, that's duh, right? I mean, we have two hypotheses. One is going to be true and the other one is going to be false. All right, so the first hypothesis, all right, that we want to talk about is the null hypothesis. This is a statistical hypothesis that contains a statement of equality. All right, and so what do I mean by a statement of equality? That means it's going to read less than or equal to, or greater than or equal to. In other words, we're always going to have that equal statement in it. All right, it is denoted H sub 0. All right, it is read H naught. It is typically not read H sub 0. If that's what you want to do, go for it. You will always hear me refer to it as H naught. All right, on the flip side, we're going to have an alternative hypothesis. This is a statement of strict inequality. All right, what are examples of strict inequality? Well, that's just simply strictly greater than, strictly less than, or not equal to. And it must be true if our null hypothesis is false. And it is denoted H sub A. All right, and so you can read it H sub A. Oftentimes you'll just hear me refer to it as the alternative hypothesis. Okay, so how do we go about stating a hypothesis? To write the null in a alternative hypothesis, we want to translate the claim made about the population parameter from a verbal statement to a mathematical statement. In other words, we're going to have to translate a word problem, and I know how much you guys love that, and I feel certain I just got some eye rolls. All right, once we translate the claim from a verbal statement to a mathematical statement, then we want to write its complement or opposite. Okay, so for example, if the null hypothesis is going to be mu less than or equal to k, all right, some k, then our alternative hypothesis is going to be strictly greater than. Similarly, if our null hypothesis is going to be mu greater than or equal to, then the complement, the alternative hypothesis, is going to be mu less than, strictly less than. And then lastly, if our null hypothesis is going to be an equal statement, so mu equal to some number, then our alternative hypothesis is going to be not equal to. Okay, regardless of which pair of hypotheses you use, you always assume mu equals k and examine the sampling distribution on the basis of this assumption. All right, I know that probably sounds like some foreign talk to you guys, but don't worry, it'll all make sense soon. Okay, so let's go through an example. Let's write the claim as a mathematical statement. All right, we're going to state the null and alternative hypotheses and identify which represents the claim. This is the kind of stuff, the next couple problems, this is going to be the stuff you guys see in the second half of week 8's homework. So number 1, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. All right, what do you think? What's our claim? All right, well, clearly our claim is that the proportion of the students involved in at least one extracurricular activity is 61%. So how are we going to go about writing our null hypothesis and our alternative hypothesis? All right, the equality condition is the claim. All right, that the population proportion is equal to 0.61. Right? The alternative hypothesis is going to be the opposite of that. All right, it's going to be that the population proportion is not equal to 0.61. Okay, so in other words, and let me grab my marker on this so you guys can kind of see where I'm talking. What the school's claim is saying is that the proportion of its students involved in at least one extracurricular activity is 61%. Is the English word for equals in math. That's our claim. Okay? All right, let's look at another one. A car dealership announces that the mean time for an oil change is less than 15 minutes. Okay? So note now, instead of reading is, we're reading is less than. All right, so how is this going to affect our null and alternative hypotheses? Well, the claim is that the mean time is less than 15 minutes. All right, this is our inequality condition. It doesn't say less than or equal to, right? It says strictly less than 15 minutes. That's an inequality condition, and that's our alternative hypothesis. All right, now once we have that one done, we just need to think of the opposite. What is the opposite of strictly less than? Well, you guessed it, greater than or equal to, and that's our null hypothesis. So our null hypothesis would read that the population mean, the mean time for an oil change is greater than or equal to 15 minutes. Okay? Let's go for another one. A company advertises that the mean life of its furnaces is more than 18 years. All right? Is more than 18 years. Okay? So how is this going to affect our null and alternative hypotheses? All right, well, that's an inequality condition, right, guys? Its reading is more than 18 years. So our alternative hypothesis is our claim. It's the first one we write, and we're going to write mu is greater than 18. All right, now we need to think what's the opposite of mu greater than 18? You guessed it, less than or equal to 18, and that is our null hypothesis. All right, now let's talk about types of errors. No matter which hypothesis represents the claim, always begin the hypothesis test assuming that the equality condition in the null hypothesis is true. This is important. That's why it's bold-faced. You always start by assuming that the equality condition in the null hypothesis is true. Okay? At the end of the test, one of two decisions will be made. You reject the null hypothesis, or you fail to reject the null hypothesis. All right, I'm going to state that one more time, guys, because you got to get that in your head. All right, at the end, we are going to make one of two decisions, and note they are both in terms of the null hypothesis. We have assumed the null hypothesis is true. What is one of our two decisions? We either reject the null hypothesis or we fail to reject the null hypothesis. Nowhere on there does it read you accept the alternative, right? All right, that's important. You either reject or fail to reject the null. Because your decision is based on a sample, there's always the possibility of making the wrong decision. Okay, what types of errors can occur? A type 1 error occurs if the null hypothesis is rejected when it is true. All right, so we reject the null when in fact it's true. A type 2 error occurs if the null hypothesis is not rejected when we should reject it, when it is false. Okay, and so the best way to think about type 1 and type 2 errors is with examples. The USDA limit for salmonella contamination for chicken is 20%. Okay, the limit's 20%. A meat inspector reports that the chicken produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will a type 1 or type 2 error occur? Which is more serious? Okay, let's let P represent the proportion of chicken that is contaminated. All right, what are our hypotheses going to be? All right, our claim, or the USDA inspector's claim, is that in this particular facility, the salmonella contamination is greater than 0.2%. That's an inequality statement. It's greater than 0.2. So that's our alternative hypothesis. What's our null hypothesis going to be? What's the opposite of that? So we're going to read that the proportion is less than or equal to 0.2. Okay, and so we've got less than or equal to 0.2, all right, meets USDA limits, exceeds 0.2, exceeds the USDA limits. Okay, a type 1 error is rejecting H naught, or the null hypothesis, when in fact it's true. All right, what would that mean? The actual proportion of contaminated chicken is less than or equal to 0.2. But you decide to reject H naught. A type 2 error is failing to reject H naught when it is false. All right, so in terms of our chicken and salmonella, what the heck does that mean? The actual proportion of contaminated chicken is greater than 0.2, but you do not reject H naught. Okay, with a type 1 error, you might create a health scare and hurt the cells of chicken producers who are actually meeting the USDA limits. All right? But with a type 2 error, you could be allowing chicken that exceeded the USDA contamination limit to be sold to consumers. So clearly, what's worse here? A type 2 error could result in sickness or even death, so it's definitely worse in this situation. Okay. What is level of significance? Your maximum allowable probability of making a type 1 error is this level of significance. Okay, we're going to use the letter alpha. Okay, so the lowercase Greek letter alpha. So again, it's the maximum allowable probability of making a type 1 error. Typically, what is alpha for a hypothesis test? We'll look at 5%, 1%, all right? Those are the main ones. By setting the level of significance at a small value, you are saying that you want the probability of rejecting a true null hypothesis to be small. All right, again, commonly used levels of significance, 10%, 5%, and 1%. In research, guys, very rarely do you see 10%. We'll use it some just so you guys get used to working with different alphas, but in general, we see 5% and 1% in research. Okay? The probability of making a type 2 error is referred to as beta. Okay? And let me go back here one second. And while we will not get to beta much in this course, those of you going on to psychology stats or business stats, you will certainly see beta some, and beta is referred to as the power of the test. Okay. After stating the null and alternative hypotheses and specifying the level of significance, a random sample is taken from the population and sample statistics are calculated. So once we state our hypotheses, what are we going to do? We're actually going to take a sample, we're going to take a random sample, and we're going to get some sample stats from it. The statistic that is compared with the parameter in the null hypothesis is called the test statistic. Okay, so whatever statistic we're looking at, whether it's X bar, all right, our sample mean, S, our sample standard deviation, or P, our sample proportion, that is going to be referred to as our test statistic. Okay, and so here, when the population parameter is mu, all right, our test statistic, as you guys know, will be X bar, our sample mean, and we will I'm getting ready to go over 7.2 with you guys, so I'll be posting that up here in just a minute. We'll have to see if we can find time to come back for the t-distribution, section 7.3, and in this class we will not cover the proportion or the variance. All right, so what's the p-value then? The probability value is the probability, if the null hypothesis is true, of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. Okay, so again, we've assumed the null hypothesis to be true. That p-value is the probability of obtaining let's say an X bar, a sample mean, with a value as extreme or more extreme than the one determined already from the sample data. All right, the p-value depends on the nature of the test. There are 3 types of hypothesis tests. They can be called left-tailed, right-tailed, and two-tailed. Okay, the type of test depends on the region of the sampling distribution that favors a rejection of the null hypothesis. Right? Hang on, all right? You may want to go back and listen to this again, but once we start looking at some pictures, I think it'll all start to click. All right, so we have 3 types of hypothesis tests: a left-tailed, a right-tailed, and a two-tailed. Think about your bell-shaped curve. Okay, we know that that bell-shaped curve has 2 tails, right? It's got a left tail and a right tail. If I put them together, I've got 2 tails. That's what we're talking about. The type of test, again, depends on the region of the sampling distribution that favors a rejection of the null hypothesis. This region is indicated by the alternative hypothesis. The alternative hypothesis contains when the alternative hypothesis contains the less than inequality, we're dealing with a left-tailed test. So less than, all right, it's very, very easy, very common sense to think about. A less than symbol points to the left, hence a left-tailed test, because we're dealing with the left tail of a distribution. Okay, so this point on our z-axis would be referred to as our test statistic. The area in here, shaded in blue, all right, is the area to the left of the standardized test statistic. All right, What about greater than? All right, well, greater than points to the right, hence we're going to have a right-tailed test. And as you can see, for a right-tailed test, our test statistic, all right, denotes the area where we're starting to hit the area where we're going to reject. Okay, so the area here shaded in blue, all right, is to the right of the test statistic, and so this is obviously going to be a right-tailed test. All right, last one, a two-tailed test. Well, common sense should tell you what this is going to be, all right? The alternative hypothesis contains the not equal to symbol. Each tail has an area of half of P, okay? So P is twice the area to the left of the negative standardized test statistic. So if P is 5%, right? So let me explain what that means. If P is 5%, then in the left tail, we have 2.5%, and in the right tail, we have 2.5%. Okay? All right, so let's go through a few examples and identify the nature of a test. All right, for each claim, let's state the null and alternative hypotheses and then determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. Okay, and then we're going to sketch a normal sampling distribution and shade the area for the p-value. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So again, recall, we said is refers to equals. That's an equality statement, so it's our null hypothesis. So P equals 0.61. Our opposite or complement would be the alternative hypothesis of P does not equal 0.61. All right, not equal to means a two-tailed test. All right, and so here we can see where we're going to have half the p-value in the left tail and half the p-value in the right tail. Okay, a car dealership announces that the mean time for an oil change is less than 15 minutes. Less than. That's an inequality statement. All right, so again, our null hypothesis was mu less than 15. The opposite of that is our null, which is mu greater than or equal to 15. Okay, well, our alternative sign is less than. That points to the left. It's a left-tailed test. All right, and here in our bell-shaped curve, we can see that it's the left tail we shade, and that P is the p-value area. All right. Lastly, a company advertises that the mean life of its furnaces is more than 18 years. More than is an inequality statement. All right, so our alternative hypothesis is mu greater than 18. That makes our null less than or equal to 18. Looking at our alternative hypothesis, all right, we have greater than points to the right, so it's a right-tailed test. And so our p-value area is now the right tail of our distribution. All right, what about making a decision? The decision rule based on p-value. All right, what you'll do is you will compare the p-value with alpha. If the p-value is less than or equal to alpha, you'll reject the null hypothesis. If the p-value is greater than alpha, then you fail to reject. Okay? So if you reject H naught, there's enough evidence to reject the claim. All right, if the claim is H naught. If the claim is the null hypothesis and you fail to reject H naught, there is not enough evidence to reject the claim. If the claim is the alternative and you reject H naught, there's enough evidence to support the claim. Okay? And then lastly, if the claim is the alternative and you fail to reject H0, there is not enough evidence to support the claim. Maybe look at this table a little bit. Remember, the claim can be either the null hypothesis or the alternative hypothesis. In our examples, we saw both. The decision is based entirely on the null hypothesis. Okay, so you perform a hypothesis test for the following claim. How should you interpret your decision if you reject the null hypothesis? What if you fail to reject the null hypothesis? All right, our null was our claim for our first example. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so our null is the claim. All right. If we reject the null hypothesis, then we are rejecting the claim. So we would conclude there's enough evidence to reject the school's claim that the proportion of students who are involved in at least one extracurricular activity is 61%. If we fail to reject the null hypothesis, then we fail to reject the claim. So we would conclude there is not enough evidence to reject the school's claim that the proportion of students who are involved in at least one extracurricular activity is 61%. All right, let's try one where our alternative is our claim. You again perform a hypothesis test for the following. All right, let's go through how our decision would get worded, all right, based on rejecting or not rejecting. Okay, a car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, the alternative is our claim. Right? So again, the null hypothesis would be the mean time for an oil change is greater than or equal to 15 minutes. Remember, it's the opposite. All right, if we reject the null hypothesis, all right, then what we're doing is we're supporting our claim. And so we would conclude there is enough evidence to support the dealership's claim that the mean time for an oil change is less than 15 minutes. If we fail to reject the null hypothesis, then what we're doing is we're not supporting our claim. So then you should conclude there is not enough evidence to support the dealership's claim that the mean time for an oil change is less than 15 minutes. All right, so let's go through the steps. This is the recipe that we're going to be working with, especially in the next lecture. Steps for hypothesis testing. Number 1, state the claim mathematically and verbally. Identify your null and alternative hypotheses. Specify the level of significance. This will be given to you. I will give you alpha. I will say the level of significance is blank. Determine the standardized sampling distribution and sketch the graph. Okay, so the sampling distribution is based on the assumption that the null hypothesis is true. Calculate the test statistic and its corresponding standardized test statistic. Add it to your sketch. Okay, so in other words, you're going to be shading or sketching to get your rejection region. Find the p-value. Use the following decision rule. If the p-value is less than or equal to the level of significance. All right, so we're going to get a p-value. Is it less than or equal to the level of significance, alpha? If no, we fail to reject. If yes, we reject the null hypothesis. All right, and then lastly, we write a statement to interpret the decision in the context of the original claim. All right, what you're going to want to do for these 7 steps, and let me go back. What you're going to want to do for these 7 steps is you're going to want them on your note card. Okay? You're going to want to have these notes either written out or printed, especially as you go through the beginning of week 9's homework. All right? It will also really help you for the second half of week 8.